So welcome to this chapter of this video. In this video, what we're basically going to look at is what is actually that of the support vector machine, or you can call it that of the SVM in general. So when unlike other competitors like this of the kernels, neighbor decision tree, logistic regression that we're actually seeing, and some other regression programs, because support vector also support that of the classification and that of the regression program. So the way support vector tend to handle that, I can say make use of that of the features to actually try to predict, or can say target that of the target, or can say to actually know how the patterns or the parameter that actually led to that of the target. The way it actually works, it makes use of what is actually called that of the hyperplane. The format that this support vector machine actually uses, let's assume that this is our Z, or can say is our output. They will have this is the weight exponential t and our x, and this of our x plus our what bias. So this our x is that of the input features, and this of our w is our weight, which is going to automatically be calculated, and this of our bias is going to be assigned at each of the computation. So while not the mathematical aspect concerning this of the support vector machines, it can be a little bit complex, but we're just going to look at how we can actually implement it in this of the our Sklearn, by making use of that of both the classification and that of the regression program. So, and one thing you should also know that this support vector machine also belong to that of the SVM subclass in our Sklearn. So let me actually close this. Let's actually go up. So first of all, we need to actually import it before we can actually make use of it. So we can actually come down here. We can say from our Sklearn dot what SVM. We want to what import. What do we want to import? We can say our SVR, which is there should be. Let's import C first, and then SVR. This SVC stands for that support vector classifier, and for this SVR is for the regression program. So let's actually give all these guys space. So first of all, we'll begin with that of the classification. There's no really much difference between how you can apply it with the other ones. Like when we look at this, like one of our data that we actually did here, we can actually make use of this data that we have here, and then we'll try to fit. Okay, let's actually make use of this. Actually, let me just copy this. So let's just give it a starting point. So don't need to actually, or we can basically make use of this. Remember in our previous video, this is actually what we actually cover, which is this of our time series split. Is another way you can actually split your data rather than relying on that of the train test split. So with this, let's make use of this of the data, and then here we actually encoded that of the data. Here we actually made use of that of the time split. So you can actually implement it in the same way. You can actually come here to set that of the SVC. It's just simple as that. It take other parameter, but I don't want us to start dealing with the parameters right now. I want us, when we start with our hyperparameter tuning, so we can see how to actually set your parameter, because setting random parameters now doesn't really amount to too much. But we will learn how to actually set and make use of parameter, and how to actually fine tune parameters. Then it will be easier for us to actually understand. So remember, this is our age, salary, years experience, and this is our target. This is just basically the normal data that we actually have. He converted it to that of the pandas data frame, and then after that we try to, because normally our target has to be a numerical value. So before we can actually feed into any model, we need to actually encode it. When I mean encoding, converting it to a numerical value, which can be 0, 1, just any number. So this is our target. We encoded it by making use of this of the label encoder. We turned it to 0 and 1. Yes, automatically is going to be 1, and no is going to be 0. It's going to sort it out of the alphabetical order. So let's actually print this off our data frame. Then after our data frame, we are assigned our x. Our x is going to be that of the input features. When I mean by input feature, like if you have been following this tutorial up to this point, input feature are those features that the machine learning learned in relation to that of the target. So let's assume something like this. Okay, this of our when we look at this of our age, and this our salary, and this of our year experience. Okay, when we look at this our data, you can see that let's say the age was 21, the salary you are making is 28,000, and then year experience is just 1. When we look at this, and then your age tend to increase to something like 57 years old, and then your salary increased to 74, and then your year experience increased to 50. You can see that with this, the model is going to learn. Okay, so the higher the age, the higher the salary, the higher the years of experience. So, but this target doesn't have any relation to do with that. This is just a dummy data. Remember that we're still going to make use of real life. I just want us to understand it in this of the, I can say, the simplest or the basic way. So when we start making use of this of the real life data, so it won't be complicated for us. Data, this of the classification data, we turned it to pandas data frame. When we look at this is actually what I mean by pandas data frame. Just turn it to a table readable format, so it will be easier for us to read. Just basically the same thing that this signifies this is row 0. Remember that it doesn't when we look at our target, it doesn't have anything to do with that or the future. These are just dummy data. So the next we did, like, since we know that the features are what the model is going to actually look at to know how it points to that of the target. So our target is our Y. If you have been following this series up to this point, this shouldn't be any hard for you. This is our time series split. This is actually basically what we actually use in our previous video. So it's not much you have to use it. You can make use of your normal train test split. So normal things, this time split, actually split it based on the future value. So the value of your S train is going to be the value of your X test is going to be the future value of your S train. That just basically I explained all this really well in our previous video. So when we run this model, we can see that the accuracy, remember that our data is small. So the value that the amount of row that is being used for testing is just basically 3. Yeah, as you can see here, 1 2 3, 1 2 3. So you keep on as the S train increases, the value of the as S train increases, the value of S test still remains the same. So, but let's actually rather than using this method, let's use one of the simplest methods, so we won't get things more complicated the way it already is. So let me actually do this. So what we are basically going to do, since our model we set it to this of the SVC, so let me just make use of that of the S train. This is our normal way we actually does it before. So let me just copy this. So let me just paste it here. So this will make use of this of the support vector classifier, so we don't need to actually make use of this of the using basically different models. So let's actually bring this down. So our model was this of the support vector classifier that we have here. So what we actually did here, in case if you are still new, the best I can actually advise is to actually check the other videos, because so this will actually make things complex for you. But this S train, S test, S split, I've explained these guys really well and how it actually works. Just like the way we split our data, when we set the test size to be 0.2, this means that we are going to use 80% of our data for training and 20% for that of the testing. So this S train test split does also have other parameters, but these 1 2 3 4 parameters are the one of the most important ones. So we have this of the X, which is for our futures, and Y, which is for our target, and the test size we set it to 0.2, which is actually 20% of our data is going to be tested. Remember that for the testing, our model have never seen those 20% of the data. So we set our model to be this of the SVC, and we fitted it on that of the S train that has more data on it. When I mean more data, that has 80% of the remaining data out of the testing data that we set to that of the 20. So you can actually control the amount of data used for your training by this test size parameter you set here. So your S train is going to be, if you set your test size to be 50, S train is going to be 50. Remember that X is for that of the futures and Y is for that of the target. So, and then the reason is to actually know how well our model is going to perform on new data set that we have here. So when we run this, Okay, let's actually check the accuracy. So I think I have the script that actually does that, so I don't need to actually start again. So let me just copy this. I don't need to actually start from beginning to write that again. So that just basically the same. Okay, what have I done? Actually, I can actually leave it like this. So we are going to predict, making the model to predict that of the S test. S test is the unseen data that the model have never seen before. So we are going to actually use it to predict. When we predict on that of the S test, so we are going to see how well our model performed on it by checking that of the accuracy score. The accuracy score is how well the model was able to classify the data really well. Like this is actually a good idea. The reason for this is maybe in the future you can actually know how well your model actually perform on a new data. So when we look at this, I will have that of the confusion matrix and that of the classification report. I explain all these guys really well. So when we look at this, the accuracy score is 66%. So the model was able to classify this data with accuracy of 66%. I say 66.7%. Don't mistake accuracy for that of the precision. I've explained this difference between these three guys and that of the F1 score and some other things. So when we look at this of the confusion matrix, it should be true positive and this should be true negative. So true positive, true positive is the one when he predicted that something is correct, or maybe something is 1 and is actually 1. So when we look at this is what is actually predicted. This is actually our Y predict here. So this is just basically, so there are actually 3 1 that he predicted. So out of that 3, 2 that he predicted, 1 were actually correctly. So 2 that he predicted were 1 were actually correct, and 1 was actually this of the false positive. The predicted 1 was actually 1, but it was not actually 1. It was actually supposed to be that of the 0 based on the S test. I can say based on that of the Y test. So remember that this Y test is more like that of the Y true, and then this of the Y predict is actually what was actually being predicted. So this is as simple. You can actually make use of this of the support vector mesh classifier. So if you want to actually make use of this of the support vector regressor, there's almost basically the same thing. So I have a script that is here. So I'm going to make use of this regression data since I have everything already. So I don't want to make use of that of the this of the classification data, because for your classification, make use of classification. For your regression, make use of your regression. Let me just actually lock up this. I can say comment it out. So for our we are going to make use of that of the support vector regression. So I'm going to come here, support vector regression. So this is why I want us to make use of this support vector regression, because this is our regression data that we have right here. That's our regression data. We have the salary, year experience, and that of the target, which is similar to that of the classification data set we have. But when we look at our target, our target tends to be a continuous value, unlike that of the of the classification. Remember that this is going to be 0 1 0 1 0 1 all true. When we look at our regression problem, this is actually 36,000. So when we look at this, we have the year experience and then salary. The target is a continuous value. So if we just plotted display basically the same thing with that of the classification data. And also there's something I forgot to actually explain. When we look at all these stuff that we have here, all these errors that we have here, we didn't actually look at our classification report. This is actually basically showing that of the precision record F1 score. Consider here I think this should be colon for that of the record, which is actually 1. These are other stuff you can actually look at in case if you're interested. The F1 score, the record, and that of the precision also. But we've actually look at our, that of our truth table. I can say confusion matrix and a whole lot of other things. But let's actually focus on this regression. These are regression data, so we just turn it to a pandas data frame, and then we selected our X to be our MP's future. This signifies we want all the rows, and the colon, want all the colon except this last one, because this is going to be for our Y. I can say for our target. So after that, we set our target to be that we collected all the rows and the last colon. If you are, because when we come to machine learning, before you can dive into machine learning, I assume that you have a little bit knowledge, you can say a good knowledge of Python, how to make use of Python programming language. In case if you are not, there have a whole complete video where you can actually learn Python programming language and data analysis, because all these guys, come back to refresh all these guys again, is quite you can say it's quite, let's just leave it simple as that. So we have the support vector, then we use that of the support vector regression for, we feed the model to actually learn some parameter within our model, and then we try to predict our S-test. So we know when it comes to that of the regression problem, it's always a good idea to make use of this mean square error and the mean average error and this R2 score. The lower the value, the better that of the model. So let's actually run this. And remember that when you want to actually make predictions when it comes to this, well, let's say for classification, when it comes to this software classification, let's say you want to actually make your own custom predictions. For this software, know what we actually did here to predict our S-test. What you can actually do, let's assume you want to, let's say you have age of maybe something like 400, let's say 400, you're going to, sorry, that might do. This is where you're supposed to add it. Remember that this is supposed to be a two-dimensional. You're going to put a two-dimension. Okay, let me actually just comment this guy out. Let me just unsilence this. So if you want to make your custom prediction, this place that the S-test is, remember that this is where the S-test was actually, this was earlier. So what you can do is just, if you want to make your custom prediction, you make it a two-dimension. You can actually, let's assume you have age of maybe something like 400. You set the 400 here, you put your comma, and then you have maybe the salary of maybe 67,000, and maybe you have the year of experience. Maybe you assume you have maybe 12 years of experience, and then you are going to run it. The model is going to give you its own prediction. But when you do this, you can actually check the correct accuracy score, the correction matches, and that of the classification report. What you have to do is just to, so all you have to do is just to select it. But let's look at our result from this of the our regression program. So let's actually go, or let's drag it up small. So we have the mean square error. We have almost this a large value, which signifies that our model is not actually performing really well, and this of our mean average error, we're having almost 15,000. The model is not performing good. And when we look at this of our R2 score, this actually signifies that how well the model was able to explain the variation that are within our data. Most of the time, it is actually 0.9 means 90%, actually represented as 0.1 means 100%. When we look at this is barely up to 0.06%. So this is actually, our model is actually performing really poorly. So let's actually go back to our classification. The way you can actually make custom prediction and classification is similar, the same thing you can actually do on that of the regression. So we want to make our custom prediction by setting 400 for that of the for the age, salary 67,000, and 12 for the years of experience, because you don't set data. So you don't set that of the target. What you actually set is the features, and then it's going to, from what it have learned, it's going to actually make use of that feature to actually tell you the target that it actually predicts. So let's actually run this. So when we look at this, we have that the output was 1. What was predicted was 1. You can actually make a string here, so you actually know what the output is actually pointing to. So you can see the output was 1. So you signify that our target is actually 1 from what is actually predicted. So in case you have you can actually when we look at this, we have the S does not have valid feature name, but it was fitted. SVC was fitted the feature name. This signifies that when we ran this initially, we're actually passing the full data frame on with the column name. The column name is more like the features. We pass in directly, and then when we try to make our own prediction, we just set the value. We didn't actually add that of the colon name. This does not actually affect any part of your model or any part of your prediction. It doesn't do anything, but it's just trying to tell you that when you are training it, you added features name, but when you are making your own prediction, you didn't actually add any feature name with it. So in case if you want to make a whole large of prediction, what you have to do is actually, maybe you can actually create a data that is more like this, convert it to pandas data frame. Don't actually set this data, you need to actually get rid of it. Your target, definitely you never know your target, so you can actually just feed it the entire, maybe say, let's assume that this is going to be your, okay, you can see our predict, you can see our df, you can just pass it like that. This here is going to automatically predict the values for you, something like that. So that is just basically it. Let me just say this as test. So each of these models that will actually make use of, so most of them depend on your choice, depend on your choice of use. So anyone you feel you want to actually use, it all depend on you. So you can switch between models, can see how the models actually perform, but there are a whole lot of models that outperform all these models were actually encountered in, like this, or the linear regression, logistic regression, decision tree, k nearest neighbor, SVM, SVM classifying a whole lot of all these models that I've actually used to actually make prediction. There are other models that actually outperform these models by a far margin. So in the next video, we are going to look at one of those models that outperform all these guys, which is actually called that of the random forest. You can see regression, or that of the classification, and it's part of that of the assemble method of tree-based model. So that's basically what we're basically going to look in our next video. So I'll be happy to see you in that next video.